Welcome and hello. This is a tutorial video on HEC RAS, and in this lesson, I'm going to be talking about cross-section data. All right, what you see on the screen here is a link to the user's manual. This is the page I'm going to be discussing in this lesson. I will leave a link to this page in the description of the video so that you're welcome to follow along if you like. All right, so over here now I have HEC RAS model that's opened up. I have my main GUI here with the file references, and then below that I have my geometric data opened up. So you can open up the geometric data by clicking Edit Geometric Data, or you can click on the button just below it here, the Geometric Data button. What we did in the previous lesson was sketch a reach. So we just went and sketched a reach from upstream to downstream. I'm not going to do that, so I'm going to cancel that. But we have a reach already sketched, and we also have a number of cross sections, 4 cross sections already in place. After the river system schematic is completed, the next step is for the modeler to enter the cross-section data. Cross-section data represents the geometric boundary of the stream. If you click on this button over to the left that says cross-sections right here, this is the main interface that we're going to be discussing and using in this lesson. Cross sections are located at relatively short intervals along the stream and are required at representative locations throughout the stream at locations where changes occur, such as changes in slope, discharge, shape, roughness, and locations where levees begin and end, as well as hydraulic structures and closely spaced around stream junctions. So right now, I only have a cross section every 500 feet, but that probably would not be sufficient for most river reaches at station 0, 500, 1000, and 1500. So let's go ahead and open up that cross-section editor once again. Actually, let me zoom in on my model a little bit here and panhand. Okay, so I'm zoomed in a little further here. If I click on the cross-section button now, I get this dialog, and I can toggle off the image for starters. At the top, we have the selected cross-section. So right here, we have River A, Reach 1. We only have one river right now, so that's my only choice. And I actually only have one reach as well. But then I have 4 different river stations, as you see, 0, 500, 1000, and 1500. River stations are labeled from downstream in the upstream direction. So the downstream most cross section will be the lowest numbered cross section as far as the stationing is concerned. And I just made that 0 to make it easy. And as you see, we can change the different cross sections that we're looking at by just selecting a different cross section from this dropdown. We can also make the same change by just clicking on the up and down arrows right here. So I'm just going upstream from 0, 500, 1000, and 1500. I can also go down the same way. In this dialog box, we have menus across the top. Exit just exits the geometric cross-section editor. Edit, we'll see what that does. Options, plots, and help. What you saw earlier was a cross-section diagram, which we can view if we click on this button right here. Currently, we're looking at the cross-section here at station 0, and we can see the stationing, which is just a graphical display of the station and elevation right here. These numbers are in feet because my model is using English units or US customary units. It would be in meters if I was using metric. And then it's also looking downstream. So for instance, this 0 on station represents the leftmost location on this cross section. And just imagine in this view that we're looking downstream. So this left point right here would be the this point here. And then the rightmost point over here would be the one over here. Let's go ahead and add a new cross section to the reach. So I'm just going to go ahead and click on options, add new cross section. Now it's asking for the station that it wants me to add it at. In fact, let's go ahead and just remove 1500 and then add it back in. So to do that, we'll select option and then delete cross section first. Before I do that, I need to select the cross section that I want deleted. So I'll select 1500. I'll go options, delete cross section. It's asking me if I'm sure I want to delete this cross section on reach 1, station 1500. I say yes, and then boom, it's gone. I think I have to close this and click save. Okay, the map updated when I closed the cross section editor. Let's go ahead and add that one back. So I'll click on the cross section, options, add new cross section. Now it's asking for what station I want to put that cross section at. I'll say 1500 and then click OK. Now I have a bunch of data I need to fill out to define that cross section. I already have the river, the reach, and the station, so that's good. I have a description I can type in here. That's optional though, so I'm just going to skip that. And then I have my stationing numbers right here. Now the cross section has already been created, but it hasn't been defined. So what I'm going to do is just define it with the same numbers as the 1000 station cross section, but then increase the elevation a little bit. So I'll go down. So I'm just taking a look at some of these numbers here, and that looks good. I'm going to go back up to the one I need to edit and type in some numbers. I'll say 0 and 95, 10, 70. And then the last one point will be at 100 station and 95. Okay. So it's going to be somewhat symmetrical. Once I have these numbers typed in, I can click apply data and then look at my cross section right here. There's a few more changes I want to make. So for example, the downstream reach lengths is the length between this cross section and the next cross section down, which is going to be the one at 1000 feet. So I'm just going to type in 500 feet here, tab 500 and 500. Okay, apply that data. And then the leftover bank values, I'm going to keep that as it is. This is the same values that I'm using for my other cross sections. But what I need to put down here is identify the left bank and the right bank of the main channel as opposed to the overbank area. So this point right here is what I want to use. This is station 30, and then this one here is station 70. So I'm going to type in a 30 and a 70. And then that Manning's N up here should update the label in the display when I click apply data. Okay, so that updated. We have a rougher Manning's N, a higher Manning's N here in the overbank area compared to the main channel. And then this contraction and expansion values. These are used to calculate energy loss due to flow expansion and contraction between the cross sections. They are only used in steady state simulations, but if you have a non-steady state simulation, you can make edits to that by updating the tables menu. Let me see, I think I have to close this and then go to tables, contraction expansion coefficients for steady flow, which I already have in place right there for my 4 cross sections. And then the non-steady flow would be in contraction expansion for unsteady flow right there. I don't have any data defined yet. Okay, so let's open up the cross-section editor again. It's got me selected at 1500 as my station, so that's correct. As I showed you, we already have the display right here. Another way, and perhaps a quicker way to make the same changes is just to make a copy of an existing cross-section. So let's go ahead and do that and just demonstrate how much faster it would be. So I'm going to options. Yeah, we can also rename the river station. So right now it's at 1500, but I'm just going to leave that as it is. I just need to try to remember to mention everything here. But let's go options, delete that 1500 station cross section. Yep. Now I'm going to go up to options, copy current cross section, which is the 1000 foot station. I'm going to call the new one's going to be called 1500. Okay. Okay. Yeah, I'm selected right here. It doesn't show it up in the map, but I do have 1500 selected. Here is the data. If I wanted to just increase the elevations by a couple feet, then I could just go options, adjust elevations, and then I could just say 2, for instance, and that would change the 93 to a 95, the 68 to a 70, and so on. So I'll click OK, and then boom, this little automatic edit for all my data points. I can do a similar operation by going adjust stationing, and now I can add or subtract a certain constant value, or I can multiply by a certain value. Okay, so let me just add a constant. I'll say 100. So all the numbers in the stationing column here are going to increase by 100. And now we're from 0 to 100. We're now at 100 to 200. Okay, so I'm going to change that back, add a constant, and just go negative 100. Okay, unless I have good reason to, I'm going to keep all of my stationing at starting at 0. And then I'll click apply data. So that sort of saves it. A few other little editing tools here are in the edit table or the edit menu. So for instance, if we wanted to insert or delete rows, what we do is we just click on a row, for instance, edit, insert a row. You most always probably want this first checkbox, which is to insert a row for every column. Boom. And now I have another row right here. So I can put in 65 and 45 and then click apply data to see that new data point right there. I don't want that though, so I can delete it by just clicking on that row again, edit, delete, and I want to delete all columns for that row, and it's gone. So I'll click apply data and the image updated. Those same tools are right here. There's an insert row button and a delete row button. So I'll click on this row, click insert, there it is, and I can click delete, there it goes. Another feature is you can add photos. You can add a picture by clicking on this picture button right here. And right now it doesn't have any picture associated with the cross section that's selected, 1500. But if you do want to add a picture, you just click the add picture button and then navigate to where you have a picture. I just have a generic picture saved here, and there it is. So I believe that's automatically saved. I'm going to go ahead and close that. Let me go ahead and toggle off to a different cross section, and then let's click the photo. Okay, I see. So now I can just select the picture. I think I have this one, same photo, same for a different cross section. Gotcha. All right, let's go ahead and remove that picture. Okay. And now the little picture label is removed from the drop down as well. One of my favorite buttons in any application is the undo button. So edit undo allows me to very simply undo the last action I took. For instance, if I added a 4 to the end of that number and I don't want to do that, hit undo. Okay, pretty self-explanatory. Now we have a number of other options down here that I need to discuss. We've already talked about add, copy, rename, and delete. Also adjusting elevations and stations. But now there's options to adjust the N or the K values, like the Manning's N, for instance. So if I click that, what it's asking me is what I want to multiply the Manning's N number by. Right now I have it set to 0.05 in the overbanks and 0.03 in the main channel. But say, for instance, I wanted to multiply that number by 2, it would be it would turn into 0.1 and 0.06. So that's how that works. And then I'm going to set that back just by doing the opposite, adjust, and then multiply it by 0.5, and it's back to what it was. All right, next up, options, skew cross sections. That's this one right here. This option allows the user to adjust the stationing of a cross section based on a user's entered skew angle. And I think the idea here is if you have a cross section that is not normal or perpendicular to the stream, then you would want to put that number in right here. So if you take a look at the numbers for the stationing and elevation, I think the elevation stays the same, but the stationing undergoes some trigonomic function, like it multiplies by the cosine of the angle or something. So let's go ahead and do that. I'll just say 20 degrees and then click OK. 93.969. Okay, yeah, it was the cosine. Okay, I don't want to do that. And there's you can obviously do your math before entering it into HEC RAS, but I'm going to remove that process. I'm going to reverse that action I just took. Again, clicking on skew cross sections, changing it back to 0, and then clicking OK. Okay, so it looks like it didn't even fix this one station. I'll type in 70. Okay, and apply data. Okay, so it looks like it also needs me to update these values as well. So the main channel bank stations also changed in both directions. So right now it's a little bit lost. Let me just type in 70 again and then apply. Okay, we're back to normal here. The little red dots here indicate the bank station. Next up is the ineffective flow areas. So I'll click on options, ineffective flow areas. This dialog allows the user to identify areas of the cross-section that do not convey flow. This would describe portions of a cross-section in which water will pond, but the velocity of the water in the downstream direction equals 0. You see we have two options here. There's normal and then multiple blocks. So if I select normal here, I could just enter a certain station and elevation to the left of the cross section, which is ineffective flow. And then same thing with the right. So for instance, if I wanted to say, what is this, 10? How about 15? From 0 to 15, I would say that is ineffective flow. I'd just type in 15 right here. And then the elevation would just have to be higher than, what is this, 93? So I'll click 93 right here, and then I'll click OK, and then apply data. I could do the same thing on the other side. But what I want to also demonstrate is this second option for multiple blocks. So if I click multiple blocks, now I can do the same thing, but for multiple blocks along this cross section, for multiple blocks across the cross section. The starting elevation I could say is 15. The end elevation I could say is 25. I could say the elevation is 93. And then permanent, I'll start off by saying no. And then I'll make another one over here in the right overbank. For instance, this may be some sort of structure like a bridge supports. I'll go 75, 85, 93, and also no. So if I click OK to that, we have two different structures here. These are ineffective flow areas. These ineffective flow areas should also appear in the plan view here. So if I zoom in here, what we see is the overbank in red and then the ineffective flow areas in green. Okay, this is happen to be working with the 1,000 foot cross section. location. So I'm going to go ahead and remove that. I'll go cross sections and then options and then ineffective flow area. You know that there's an ineffective flow area because this checkbox is checked. But if I toggled over to a different cross section and then click options, there's no checkbox by ineffective flow area. So it doesn't exist for this cross section. Okay, back to the cross section we were working on here. I'm going to undo that and then I can just clear it and then click OK. It's gone. Apply data. And then let's move on to the next one, levees. When levees are established, no water can go left of the left levee station or right of the right levee station until either the levee elevation is exceeded. So as before, I can just go ahead and type in a number, say, we'll just stick with 15 and 85. And then for an elevation, something over 93 or higher, I'll just round it up to 100. And then I'll click OK and then apply data. So now we have a levee that shows up here. And then there won't be any flow over here past the levee marker unless the levee elevation of 100 feet is exceeded. Okay, so let's turn off levees. I'm going to go ahead and clear levees. Click OK. And then options, we have obstructions here. Obstructions feels a lot like ineffective flow areas because we have a normal option and then we have multiple blocks. So this interface should sort of feel familiar. I'm going to go ahead and just use the same numbers as before, 15 and 93, 85 and 93 for blocking off the first and last 15 feet of this cross section. So I'll click OK and then apply data. And now we have that area blocked off. For obstructions, this option allows the user to define areas of the cross section that will be permanently blacked out and blocked out from flow. I'm going to click on options, obstructions. Now I'm going to show how multiple works. So as before, I'll go 10 feet of width on the left overbank for a 93 elevation, and then another 10 feet of width on the right overbank at an elevation of 93, and then click OK. And now you can see that that obstruction area has changed. The next action is to add a lid to the cross section. So let me turn off obstructions, clear it, OK, and then update, OK. Here we are with add lid to cross section. This option allows the user to add a lid, commonly used for when trying to model a long tunnel. So we have a ground elevation and a lid elevation, like the bottom half and the top half. It just gives the user a little bit more flexibility that they didn't have with an obstruction. I've typed in a few numbers here. So the first 50 feet of this cross section, so halfway across, I have a lid. And if I click OK, I see that lid in place right there. And it ranges in elevation from 85 feet up to 100 feet. Okay, so I don't know how common that is, but I'm just going to remove that now. So clear, and then OK. When water comes in contact with the lid, RAS will subtract the cross-sectional area, of course, and add wetted perimeter. Next up in the options tab is to add ice cover. Now this is a little bit beyond the scope of this lesson, and I will have a separate lesson on ice cover labeled a lesson for river ice. But just so you know that there will be information about ice cover thickness, Manning's end value, and some other parameters involved with river ice. The next option down here in the options menu is add a rating curve. This option allows the user to add their own rating curve to a cross section as an alternative to letting the program compute the actual water surface. This is the rating curve value, and now we actually have units labeled, so that's nice. We have the stage, which would range in my case from what's the minimum here? 33 up to 93 for this particular cross section, and then the flow rate is in cubic feet per second. Of course, if you're using metric units, it'd probably be cubic meters per second. Once we get some numbers typed in here, we can go ahead and click the plot button, and we can also clear our data just like that. When the program is executed in a steady state flow with a rating curve specified for a cross section, program will interpolate the water surface elevation from the user specified rating curve. So I'll close that. And then we have a few more left. Horizontal variation of N and K values. These are work sort of the same way. I'll just talk about N for Manning's N. Right now, what we see is the values for N, 0.05 for the left overbank, 0.03 for the main channel, and 0.05 for the right overbank. Now, what we see here is N/A grayed out for not applicable because these Manning N values are now defined for the station as they vary across the cross section. So if I wanted to like change, I don't know, this middle section from 60 to 40, if I wanted to say it's 0.02 and zero point zero 0.02, and then I click apply data, we have updated values that are shown here in the plot. Okay, so it gives the user a little bit more flexibility. In fact, you may even want to add a row or two in this table to modify the end value to get it a little bit more precise. I'm not going to do that though. I'm going to delete those and then click apply data. Next, I'll click on the options tab. I'm going to toggle that off. So it's going to remove this row. Yes, I'm sure. Okay, so the original values are back to where they were there. And then, yeah, the last one is vertical variation in n values. So if there's a vertical variation in your Manning's n values, you can use this interface to go ahead and specify what those n values are. Well, that's it for the options menu. There are a few options in the plot menu. Plot the cross section in a separate window. Okay, I had to save it. Here we go. What we have is a little bit bigger, easier to see view of the cross section. And right now we're working with River A, Reach 1, Station 1000. I can toggle the stations just as before. When I do that, the stations are highlighted in the main geometric data display. As you can see, that purple highlight is moving around. And this is a good way to sort of spot check for errors just to make sure that your cross sections are looking correct, as well as all the other data that we inputted, such as obstructions, levees, ineffective flows, you name it. Okay, so I'll close that. And then the other option here under plot was plot profile. And what we see here is now a profile of the main channel. So it starts at 1,500 feet upstream, and then it flows down to the zero station cross section, which is down here. This is the invert elevation, so it gives you an idea of what the slope is of that main channel. All right, well, that was it for our discussion on cross sections within the geometric data editor. There is a lot more on cross sections we'll talk about, but that was the basics because it interacts with all sorts of other parts of the model. And cross sections is a very important and instrumental part to running hydraulic models in HEC RAS.